Okay, so in this video, we're going to talk about the trigonometric identities, specifically about the reduction formula. So reduction formula are a great math tool when you are seeking to simplify trigonometric expressions. And in this video, I'm going to explain how to apply them, or like specifically talk about what are those. Okay. So here I have cast diagram. Okay, so this class diagram has the first quadrant, second quadrant, third quadrant, and then fourth quadrant. And as we know, on the first quadrant, everything or trigonometric ratios are positive values, right? And then with the second quadrant, only the sine ratio has the positive value. And on the third quadrant, we know that only the tangent ratio has the positive value. And on the first quadrant, we know that only the cosine has the positive value. So from here, we know that we can memorize this, how this cast diagram works, as like our student takes Coca-Cola, right? That's how you should memorize which one is positive in each quadrant, right? So our student takes Coca-Cola. So since we know like which trigonometric ratio has the positive value, we can actually predict the angles using that concept. Okay, so whatever we get, or let's say like we have a unit circle here on the first quadrant, okay, and that's going to be your reference angle. Okay, the angles that you get on your first quadrant going to be your reference angle. That means with the unit circle, we know 30 degree, 45 degree, and 60 degree, right? And those are going to be your reference angles. Okay, so based on your reference angle and based on the which trigonometric ratio you're looking for, the reduction formula that you're going to use for the second, third, and fourth quadrant will be different. Okay, so based on which angle you're using and then which trigonometric ratio you're trying to find and which angle you're trying to find, will actually change the reduction formula that you're going to be using with. Okay, so we know that we already know that the angles in the first quadrants are called reference angle, right? So using the reference angles, you can find the angle in the second quadrant and third quadrant and first quadrant. Okay, then let's talk about the angles in the second quadrant. So when we have a quadrant 2 angles, so this is your quadrant 2 angles. So when you have a quadrant 2, we know that this is between the 90 and then 80 degree, right? So these are between the 90 and then 80 degrees, or let's say like this. So this quadrant 2 is between the 90 and 80 degrees. So this is like obtuse angle, right? So to calculate these angles, we know that in the second quadrant, the sine value will be always positive. So to calculate this angle in the second quadrant, we have to do sine 180 degree minus theta, our reference angle, and this will give us the positive sine theta value. And for the cosine and tangent, we know that these are going to be this will give us the negative values, right? So we're going to do cosine 180 minus theta, and this will give us the negative cosine theta value. And for the tangent, we have to do 180 minus theta, and it will also give us the negative tangent theta value. Okay, this is to find the angle between the 90 and 180 degree. Okay, right? So this is how you calculate the angles between the pi over 2 and the pi. If we are trying to calculate angles in quadrant 3. So quadrant 3. So now we are trying to calculate the angles between the pi and the 3 pi over 2. Okay. We know that on the third quadrant, the tangent theta value is always positive, right? So if we do 180 degree plus theta, then we get the positive tangent value. Okay, if we're trying to calculate the sine, if we do 180 plus theta, it will give us the negative sine theta value. If we're trying to calculate the cosine theta value, we have to do 180 plus theta, and this will give us the negative cosine theta value. Okay, then let's talk about the quadrant 4. Okay, so quadrant 4. We know that quadrant 4 is located between this 270 degree and 360 degree, right? So this is your quadrant 4, and on the quadrant 4 only the cosine value is the positive, right? So we are trying to calculate the angles between the 270 and 360, right? Or we can say 3 pi over 2 or 2 pi. So to find the angles between the 270 and 360, what we need to do is we have to do cosine 360 minus theta, and this will give us the positive cosine theta values. And if we do tangent 360 minus theta, this will give us the negative tangent theta value. And if we do sine 360 minus theta, this will give us the negative sine theta value. And these are the reduction formula. Okay, now then let's do an example together. Here we need to solve 2 sine x equals to 1, and the x value is between the 0 and 2 pi. So we are trying to find this x value. Okay, so we have 2 sine x equals 1. That means sine x value is equal to 1 over 2, right? The angle, the value of the angle that gives 1 over 2 as its answer is the angle pi over 6. So x value is pi over 6. So what this implies is when you have a cast diagram like this, we have a unit circle, okay, and there's a angle pi over 6, and it gives the sine x value 1 over 2, right? So y value is a sine x value, right? So it gives the 1 over 2. And what we need to do is we need to find these other angles that are possibly answers in between that are in between 0 and the 2 pi. So we know that in the cast diagram, the only quadrant that gives the positive sign values are the first quadrant and second quadrant, right? So we know that the only quadrant that gives the positive sign values are first and second quadrant, okay? And then we know that the angle that we found, pi over 6, is our reference angle. Okay, so to find the angle in the second quadrant, what we're going to do is we're going to use the formula, the reduction formula. Okay, according to the reduction formula, we know that if the angle is in the second quadrant, we have to use this formula. Sine 180 degree minus theta is equal to sine theta. Okay, so we're going to use the reduction formula. Sine 180 minus angle theta is equal to sine theta. Okay, so we do, since everything is given in pi or the radian, we can say that this is same as sine pi minus theta is equal to sine theta. Okay, then using this formula here, we can say that pi minus pi over 6 is same as 5 pi over 6. So this is your second angle. So the final answer for this question is x value is either pi over 6 or 5 pi over 6.